Okay, folks, we're going to continue the story we have started last time. We're going to be talking about the factoring of trinomials, this time by the two methods. One of them will be trial and error, and the other one is going to be AC method, but both of those methods are reversing FOIL. So let me give you an example of what that means. So you have the something like an x squared plus 5x plus 6. Now we did factor that in the past by using the factoring by grouping. So I split the 5x into 3x and 2x. And then I had the grouping of the first two and the last two. So I have these two and these two. And so I remove the common factor in the first group, which is an x. And the common factor of the second group, which is 2. And now I got the x plus 3 is a common factor of this term and this term. So I got that x plus 3. And I have the leftover, which is x plus 2. So I get this by factoring by grouping. Okay? What you need to notice here is that we have here a product of binomial times binomial, which we work with doing the what we call a FOIL, right? So the first time first, which is an x squared right here. Then we do the first time last, which will be 2x right here. When we do 3 times x, there will be an I right here. And then we do 3 times 2, that will be an L right here. So you actually have your typical FOIL here. Not necessarily in order, I was having the FOIL. But it's just a question of shuffle, right? What you need to notice here, which is more important for our story today, is that when you multiply these two numbers, you will get the last number here, 6, which is right here from the get-go. And when you are getting x's, you're multiplying this time this, which is 2x's, and this time this, which is 3x's. And so this is 3x's and 2x's. These two combined is 5x's, which is your middle term. In other words, you have 2 times 3. This number, 2 plus 3, this number. And that's the whole idea. If you can remember that, you don't have to do any of the grouping I did. You're gonna be sickly. Factorization. So that you're gonna have an x here, and here, and here. You'll have two numbers whose product is this number and whose sum is this number. And that is in this case 2 and 3. So that's much easier. So instead of doing factoring by grouping, you have that immediately. Okay? Let me give you another example. A squared plus 11a plus 30. Again, the initial thought should be about the common factor. You don't have any common factor. You have an a times a here, there's only a here, so the idea about the common factor is not going to work. What else can you do? Well, you could try grouping, but again, that would lead you to a FOIL, reversing a FOIL method. So we have this idea that I just showed you that in the previous example. You're going to be looking for a variable and a variable here, and I'll be looking for a number here and another number here, so it's a guess what that could be, and the product of these two numbers has to be 30. But at the same time, the sum of these two numbers must be 11. You know immediately, that's 5 and 6. You're done. So this is much faster than factoring by grouping. You might have a problem when you get something negative. You have to be a little bit careful about it. So I have an example when I have something negative, like this. Okay. Now what I have here is again something that is a result of a FOIL. So I'm going to be reversing the FOIL here. And once again, I don't have a common factor. I have an x times x here, and this one doesn't have any x, so I cannot do any common factor extraction. But I'm going to try to do the factoring by using this idea that just said you're going to have here x, you're going to have an x here, and now you're going to have on this place and in this place two numbers whose product is going to have to be will have to be negative 15. At the same time, the sum must be 2. So since the product is negative, one of them is negative, one of them is positive, but the sum must be 2. That's pretty much it. So 1 and 15 would never in any kind of combination give you a sum of 2, but 3 and 5 could if one of them is negative, right? So negative 3 and positive 5 will give you a sum of 2, and that's what you need. You should do the complete FOIL, so make sure that this is really what you have. You have an x squared here, that's an f. You have negative 15, that's an L. So you have this, and you have this. And now you need a middle term. You have negative 3x, and you have 5x. That's your middle term, O and I, right? So you have a 5x minus 3x, which is 2x. Okay, this is a check. You should probably write it on scrap paper to make sure, this is really not a tidy way to do that. But scrap paper would be probably a better idea. Okay, I want to say something about being careful here, because very often people make a mistake in terms of signs. So if you don't think too hard, you might go for this. And you're going to misplace the signs. You're going to have the minus in the wrong place. Now, this is also going to give you a FOIL, but it's going to be a different one. It's going to be this one. Okay? And this are not the same thing. So you have to be careful with signs. So again, you're looking for a product of two numbers whose the product is here, negative 15, and also the sum of these two numbers will be here. That's a negative 2 in this case, right? You have to be careful with that, because that is going to be something you can easily misplace. Okay? Let's go another example. I'm picking an example which is from the lecture, so I want you to read. And I'm not going to do all of the examples that are in the lecture, so I want you to read the rest of them. I have the following one. Okay, so now I have again something I cannot find the common factor, because again I have an x and x and I don't have any x there, and the alternative would be factoring by grouping, but the idea would be here that I'm going to follow this trial and error method that I have, which means I'm guessing the numbers. So I have an x here, x here, and now I'm looking for two numbers. The product is 36 and the sum is negative 13. something is negative. So this, both numbers must be negative because the product must be positive. So I have to have something negative, because if I have everything positive, I will never get negative here. But if I choose one of them to be negative, the other one must be negative because I need to have positive here. So you can think of lots of different ways you can get 36 by multiplying something. So 1 times 36, 2 times 18, 3 times 12, 4 times 9. No, that works, because 4 and 9 is 13, and both of them are negative. So this is it. Very simple stuff. The idea is much simpler than doing the factoring by grouping. Okay? Let's go one more. This is about a complete factorization. Sometimes you have this problem that you need to do a complete factor. That's 2 times 6, or maybe I can have 3 times 4, or factorization in both cases, but neither of them is complete. Complete factorization is 2 times 2 times 3. That's your 6. Or 3 times 2 times 2. There's your 4. Right? What's the difference? The difference is here, there are primes. 2, 2, and 3. 3, 2, and 2. You can see this is a unique factorization. I mean, this is not different than this other than a shuffle. Okay? So factorization into primes is unique. Now this and this are different factorizations. They're not the same. They're different factors. The factorization into prime is always unique. This is 2, 2, and 3, and this is also 2, 2, and 3. The only difference is commutation, the shuffle. Okay? So the complete factorization is when somebody's asking you, do the complete factorization, is factorization into primes. So I'm going to do one complete factorization here. We have in the example number 23. Okay, the one thing you'll notice immediately here is going to be that you have a common factor. The common factors here is an A. Actually, yeah, there's nothing else, right? So that common factor ought to be taken out. So you got the A. Now you have the x squared. You have the 3ax. And then you have a 2a. Right? So 1a is out, the x squared stays. 1a is out, 3ax stays. 1a is out, 2a stays. And once again, I'm copying wrong. Yeah, I have a cube here. Sorry about that. So, and once again, you can say, well, I do have a factorization here, and the common factor is A. I took it out. I don't have any other common factor because this one has an x, and this one doesn't have any x, so there's not there is no any common factor left. I can't factor this any further. But actually, you can. This is not a prime, and here is why it's not a prime. You have a product of two numbers here, whose sum is here. And those two numbers are A and 2A. If you make a sum, you get a 3A. If you make a product of these two, you have a 2A squared, right here. So you have the same story again. You have an X, and you have two numbers. And you can check this again. Oh, I didn't say the numbers have to be concrete, right? It doesn't have to be 7 and 5 and whatnot. It could be something else, something you don't know what it is. So again, you have an x squared right here. You have 2a squared right here. And now you need a middle term. 2ax and ax. So we make a sum. You have a 2 of them and 1, that's 3 of them. 3ax. So I'm doing FOIL here, but I'm not really writing on scrap paper. I'm just doing with those arches, which is okay for me, but you probably need to do the scrap paper work here. Now that's a complete factorization. This, and this are all three primes. Okay? I'll give you one more. So I have another complete factorization. It says do the complete factorization here. Let's see. 3ax squared minus 21ax plus 24a. Okay? Let's put here negative to make it nicer. Or a little more problematic, right? Okay, for one thing you have a common factor. You can see all three of them have an a. All three of them also have a 3. 3 is here, 3 times 7, 3 times 8. And not all three of them have an x. This one doesn't. So the common factor, the greatest common factor is LDL. This is the greatest common factor. There's nothing else left. So what you have left is an x squared minus 7x, because I took 3 and I took a. I took 3, so it's going to be 8, and I took a, so this is what is left. So now it's easy. I need a product of 2, x and x. The product must be here, this number and this number must be negative 8. And the sum must be negative 7. Okay? So one number is negative, one is positive. Negative 8 and positive 1. Because when you multiply 1 and negative 8, you get negative 8, and when you make a sum of 1 and negative 8, you get negative 7. So this is what you're looking for. Positive 1 and negative 8. So now you have a complete factorization. Again, 1, 2, 3, 4, all primes. So you have 4 primes here. Okay? Now, this trial and error method could get harder. If you have something that doesn't start with a square of variable, something more than a square of variable, like a 2 squares of variable. Okay? No common factor again. There's 3 here. 3 is neither of the first 2 terms, so you have no common factor. But this is still something you can factorize. It's not a prime. And the factorization is going to work again in a way that you're going to have the first and first to be this guy. So you need to have an x and 2x. You can say I can have 2x and x. Yeah, but that doesn't make any difference because you can switch this, right? So I can put always the smaller one forward. 1. And then also you need the last time last has to be 3. So you have 2 options. These 2. The question is which one? Which one will work? The answer will be the middle terms. You have on this side, and on this side you have 7x. So this one is not the one that works. The bottom one, 6x, 1x. So there's your middle term. The I and the O. And you have the 7x, which is what you have here. So the bottom one works. So you have to be careful here. So again, this is a trial and error. There's trial, and I didn't make an error. It's just the error is the power. The product here doesn't match this, so that's sort of an error. But and then the second trial, and that one works. Okay. Now let me give you another one. So I have 4x squared plus 8x plus 3. And again, I'm expecting 4 things to guess. I need to know what I have here and here, first and first. I need to know what I have here and here. Okay? In how many ways I can get 4x squared? I can get 1x times 4x. I can get 4x times 1x. It makes no difference. I'm going to put 1x here. So this is the thing. And I can get 2x. Okay? Now in how many ways I can get 3? From the last and last. 1 and 3. And then I can also get the 3 and 1. All possible combinations. Which one works? Well, I have to check the middle term. The middle term is going to be the one that's going to decide which one is. So here you have 4x and 3x, that's 7x. This is 8x. So this one doesn't work. Okay? The next one, so 3x, so this is the one that works. You don't have to go any further, because if you have a factorization into primes will be unique. There will not be second one, other than a shuffle. And you can check it out. I mean, you have here 12x, and you have here 1x, so that's 13x. That's not here. So this one doesn't work. This one doesn't work. The last one, you have 6x and 2x. So you can say, oh, that one works. It does. But it's no different than this one. 2x plus 1, 2x plus 1, 2x plus 3, 2x plus 3. Shuffle. Okay? So the last one is just the second one, which is probably the first one you found that works. Okay? You can also do this by doing the table. Okay? It's a little bit more organized. You get a little less stuff like that. That doesn't look very organized, okay? First and first, you're guessing what is here, what is here. Last and last, and middle term check. So the options are 1 and 4, 1 and 4, and 2 and 2. 2 and 2. The options for this guy is 1 and 3. And 3 and 1. All the possibilities. Okay? I am not writing this as an X, I'm not writing this as a multiplication. I just want to say 1 by 4, 1 by 3, 2 by 2, 2 by 4, 2 by 8, whatever, right? It's like dimensions. Okay, but now I'm doing the middle term check. You multiply this, which is 3, multiply this, which is 4, that's 7. Doesn't work. The middle term is 8. You multiply this is 6, you multiply this is 2, that's 8. That works and you're done. This is the one that works. So instead of going through all of that, this is a little more organized. You don't have to go any further here, because again, if you go any further, you're not going to find anything new. And so now you can do this a little more organized, in a little more organized way, I should say. So you have this one that works. So you have a 2 and 2. First and first. And last and last. 1 and 3. And that works. So there's your factorization. I think this is a little more organized. Let me get something with some negative stuff. The negative stuff, of course, is always a problem, right? Dealing with negative numbers, I mean. 5x squared minus 13x plus 6, okay? I know that I'm going to get first time first to be 5 and last time last to be 6. Now first time first to be x here, I can just flip it and I get the 1x forward. So first time first, the only option is 1 and 5. 1 by 5. Okay? Last and last. There are lots of different ways I can get 6. I can get 1 times 6, 2 times 3, 3 times 2, 6 times 1. And since I need to get something negative, and this must be positive, both of those must be negative. So I have 4 different options. Negative 1, negative 6. So that's one option. 1 and, excuse me, I'm going to switch them. Negative 6 and negative 1. Negative 2 and negative 3. And the last one, negative 3 and negative 2. And there's nothing else. Now if you find anything else, let me know. Okay? You have to have this systematic stuff down there. All of the options have to be outlined, and those are the options that you're gonna find. There are possibilities here in this factorization. One of them will work, or maybe none of them. If none of them works, you're dealing with a prime, so that could also be the case. Cannot be factored, right? That's a prime. So now you do the middle term check. OI, negative 6, negative 5, negative 11. You don't have negative 11 here. Negative 1, negative 30. You multiply this and this, you multiply this and this, and then you add. Negative 31. Well, that's definitely not there. Okay? Negative 3, negative 10. You multiply this and this, negative 3, you multiply this and this, negative 10. It's negative 13. This is the one that works. You don't even have to go to the next one. But if you go to the next one, it's negative 2 times 1, which is negative 2, and 5 times negative 3, that's negative 15. So you get negative 17. That doesn't work, obviously. Okay, so you have the one that works is here. So now you can write it over there. So you get 1 and 5, first and first. And last is negative 2, negative 3. You should also check that, because maybe you made a mistake, you know. When you work in this out, it's easy to make a mistake, either in sign or wrong multiplication or wrong addition, things like that. Okay? Let me give you one more. Now this next one is trouble, because it has a 2 minuses. Okay? So again, I don't have a common factor. It's 2 times 2. There's only 2 here. So the only other option is that I have actually FOIL to reverse. Okay? So first and first, I think I can only get 3 and 1, or should I say 1 and 3. It looks like, oh, that's going to be easy, because you have only one choice for the first and first. Not so, because you have lots of choices for the last and last. What am I talking here about? Is you have negative 1 and 4. That's when you multiply, you get negative 4. You can also get 1 and negative 4. It's just a switch of sign, but it's a different story. Then you can also switch the numbers. So you get 4 and negative 1. And negative 4. And positive 1. Tired? And that's not all. More. You can also get 2 and 2. Negative 2 and 2. Or 2 and negative 2. All different. Okay? That's the trouble with signs. Middle term check. Okay, let's see how lucky we are. Maybe we get it on the first, maybe you're going to get it on the sixth. So let's see how much luck I have. 1 times 4 is 4. 3 times -1 is -3, and 4 minus 3 is 1. No luck. Next one. 1 times -4 is -4. 3 times 1 is 3. That's -4 and 3, that's -1. By the way, it's worth remembering when you switch the signs only. You're gonna only get here switch of signs. It'll make your life a little bit easier if you can remember that. 1 times -1 and 3 times 4, that will be 12 minus 1, that's 11. 3 times -4, -12, 1 times 1, +1, it's -11. I already said that's going to happen, right? The next one. 1 times 2 is 2, 3 times -2 is -6, -6 and 2 is -4. Got it. That's the one. Right here. Okay? The next one would be +4. You can check. 1 times -2, 3 times 2, 6 minus 2. That's +4. Waste of time. Don't go any further because the one you found, it's gonna be the one that's gonna work. And anything further could work only if it's a shuffle. So you have 1 and 3. 1, 3. And the second place is you have -2 and 2. Be very careful. If you misplace that, you put here +2 here, -2, then you're gonna have it wrong. Okay? I can check that for you. Just say what is going to be. X times 3x is 3x squared, perfect. 2 times -2, -4, perfect. 2 times 3 is 6x, and x times -2 is -2x. So 6 minus 2x is 4x. -4x, not 4x, right? Just a slight misplacement. And you get this story here, which is not correct one. Okay? Now you could have also wrote that, all of those options out in parentheses. Just don't erase them. Because the problem is if you start erasing the stuff, you're going to go to the first option, doesn't work, the second option, doesn't work, the third option, doesn't work, the fourth option. Oh, did I try that before? And then you're going to ask yourself that kind of question. And then, I erased that, so why did I erase that? Maybe I tried it already. So then you can find yourself doing multiple stuff. The same stuff again and again. So don't erase anything. You just go through it, write everything down as a system, and check everything. Okay? Sometimes, no matter what you do, you're not going to find any factorization because the thing is going to be prime. And when the thing is a prime, you can't factorize it. For example, 41. You're not going to be able to factor 41 no matter what you do. It's a prime. So it's a product of nothing. You can write it 1 times 41, but that's just trivial, right? You can't do anything else. So that can happen with polynomials. Again, we can get a bigger polynomial, which is actually a prime. Now, I'll give you this example. 6x squared and -9x plus 4. This one doesn't factor at all. Cannot be factored because it's a prime. You can attempt and you can write everything down that is possible. I actually have 6 combinations here, so it's not that bad. First and first, how do you get the 6? Well, you can get a 6 by 1 times 6 and 2 times 3. That's it. 1 times 6, 2 times 3. Now last will be 1 4 4 1 2 2. 1 4 1 4, and now you have that repeated with both of them as 4 1, and I also said 2 2, right? 1 times 6, 2 times 3, 2 2 2 2. Ah. What am I talking about? I need to have something negative, right? Because obviously it's okay to get positive here, but I need to get negative here. So both of these are going to be negative, 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 All right. But we do have everything they could possibly have. Now, if you can find anything else, keep on writing. I'm claiming there's nothing else you can find. This is all there is to it. That's important too. Of course, if you don't write everything down, you can't claim it's prime because you miss something, right? You didn't investigate all the possibilities. But I'm claiming here there are all possibilities here that you can possibly have. Again, you can only get this because 1 times 6 and 2 times 3. And again, you can always put the smaller one forward, so you don't need to talk about 6 and 1 and 3 and 2 because they're already here. Okay? Now, in this case, you need to get 2 negative numbers whose product is 4. Negative because one of them must be negative. You gotta have to have something negative. So you need both of them negative. So all of the possibilities you can get 4 with 2 negative numbers. So this is -1 times -4, -1 times -4. There's 2 different options here, of course. -4, -1, -4, -1 with these 2 guys again, and -2 and -2, -2 and -2 with these 2 guys. And there's nothing else you can get. Okay? So now try the middle term check. 1 times -4, 6 times -1, that's -10. That is not here. 2 times -4, 3 times -1, so that's -11. It's not here. 1 times -1 and 6 times -4, that's -25. We're far away from this. Okay? 2 times -1 and 3 times -4, that's -14. 1 times -2 and 6 times -2, that's another -14. Neither of them works. 2 times -2 and 3 times -2, so that would be -10. Close, but not cigar. None of them is -9. So again, you multiply these 2, you multiply these 2 and add. So -2, -12, add -14. I get it. Every one of them like that. None of them works. Now you can say, this dude is a prime. No factorization possible. Okay? So, this is not the only method you can use. By the way, there are a couple of other examples that I'm going to leave for you, like example number 30, 31, 32, and 33 in the lecture. Now let me do 33 for you. So I have something like this. 4x cubed plus 18x squared plus 18x. Okay, the story is here that you have a common factor, so that ought to go first. It would be a bad idea you could try to split this into 2 by 2 because you will miss the common factor story and you're going to get yourself much harder work because you have a cube here rather than a square. So the common factor ought to go out. You have a 2 here, you have a 2 here, you have a 2 here. You have an x here, you have an x here, you have an x here. That's your common factor. The greatest common factor is 2x. So what is left? 2x squared plus 9x plus 9. So now you can say, I'm done, I have a factorization. But you have to do the complete factorization here. So this is a story about complete factorization. So you have to factor this one out because it's not a prime. Okay? Prime, prime, not a prime. So you now have x and 2x. That's how you get this guy. And now you can factor this 1 times 9, 9 times 1, 3 times 3. You can write all of that. First, the last one I said is 3 times 3, right? And one of them is going to work. So they're not all 3, of course. The middle term check. 9x and 2x is 11x. 11x is not 9x, so this one doesn't work. I need a 9x. The next one is 18x, 1x. So that's, I'm doing O and I, right? I, 18x, O, 1x. That's 19x. Kind of close, well, not really close. 19 is not this. So this one doesn't work either. And now this one is O, 3x, 9i 6x, that's 9x, perfect. This is the one that works. Okay, I shouldn't put a check mark here, I should put an equal sign here, right? This is the one that works, and now you know it. So this is a complete factorization story. Prime, 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 4 primes. You cannot write any one of them as a product or anything else, then you are done. Okay, now I want to show you something else, something called AC method. Now AC method sounds like a air conditioning method. So we've done method of trial and error. This is you guessing the numbers and you write them all down, all the possible guesses, and it's not really guesses, it's just a system, you know. All of the pathways. One of them works, or none of them works, in which case you have prime. That's called method of trial and error, or trial and error method. Okay, there's another method called AC method. Now, that sounds like an air conditioning method, but it's not air conditioning method. It's just AC method based on how we call coefficients. So we have the 2x squared plus 7x and plus 3. We have something like that before. Okay, so this coefficient is called A, this one is called B, this one is called C. So you have A, which is 2, and B 7, and 3 is C. A, B, C. A, B, C. Not a term, but coefficient, numbers, right? 2, 7, 3. Okay, so you multiply A and C, which is 2 times 3, and you call that key number. 6. The next step in AC method is factoring by grouping. And you're gonna be doing that by splitting this guy into 2 terms. You can do that, 1 and 6x. 1x and 6x. You can do 2x and 5x. You can do 3x and 4x. You can do 5x and 2x. I already said that, 2x and 5x, right? Which one of them is going to work? It's hard to know, right? Factoring by grouping, you can try lots of different ideas, and none of them might work. Well, the one that will work, now this is a guarantee, will be the one, when you split this, you will have 2 numbers whose product is key number, AC. That's going to be 1 and 6. That will work. 1 and 6, because 1 and 6, product of 1 and 6 is the same as product of A and C, key number. If you can accomplish that, you will have factorization by grouping that will work. That's a guarantee. Okay? X, 2x plus 1, 3. So this is the first group. The second group, you have common factor 3. X plus 2x, excuse me, plus 1. Didn't write it nicely. Let me try to recover that. And now I have a common factor 2x plus 1 in both of them. So you have 2 terms, this one and this one, common factor 2x plus 1. So you have 2x plus 1, and out of the first one you have an x, out of the second one you have 3. There's your factorization. We already had that before, so this is not a news. So we had it by the table I was doing that trial and error. So this is AC method. Let me do another one that we had before by using AC method. Okay, I'm lying. I didn't try this before. This is an example number 30. So I'm gonna do the AC method. This is the example I didn't do with the trial and error. You can try it yourself and see how that works. Okay, AC method is very good in the situation when you have bigger numbers. Okay, so I have a 6 times 15, which is 90. The key number is 90. And now you need to split this one into 2 numbers whose product is 90. That's peanuts. It's 9 and 10. Now imagine if you do the trial and error. You're gonna have to think about what you get this from. 1 times 6, 2 times 3. Okay, that's 2. Not too bad. How do you get this one? 1 times 15, 15 times 1. Now God forbid if I have negative here, then it would be who knows how many options. Okay? But there's a method of peanuts here. So I got the 6x squared plus 9x plus 10x plus 15. Why? Because the product of 9 and 10 is 90, and product of 6 and 15 is 90. So it has to be 9 times 10 has to be AC, which is 90. So it works beautifully. Now you can actually get this grouping. You have 3x here, common factor. So you have a 2x left. Out of this one you have 3. Out of this one you can take out 5. And then you have again 2x plus 3. Common factor 2x plus 3, 2x plus 3. You have a 2x plus 3. And leftover is 3x plus 5. Done. So simple. Okay? So I'm saying when you have bigger numbers in the game, the estimate is probably going to be faster. So how are you going to find these two numbers? Now I was just guessing them. It's so easily. 90. How do you get to split this? Well, you just have to think about how to get 90. 1 times 90, 2 times 45, 3 times 30, 4 times nothing, 5 times nothing, 6 times 15. That's also 90, right? 7 times nothing, 8 times, it's not divisible with 8. 9 is divisible, 9 times 10. And that's it. All possible combination. Which one you can split this one in? 1 plus 90? Hardly. 2 plus 45? No. 3 plus 30? No. 6 plus 15? That'll be 21. No. 9 plus 10. Okay? So if you don't see it, you just write that all of the possible product you can have here. And one of them had to be possible separation of this middle term. So we got this really easy. Okay? Now when you get a negative number in the game, I don't know, the key number method, or should I say AC method, might not be all that easy either. But it's not too bad. Let me give you one example. 3x squared minus 4x minus 4. We did that before by using the trial and error. Okay? So again, the key number here is 3 times negative 4, which is negative 12. Yes, the key number could be negative, so you have to take that into account. Okay, now you got 3x squared, you got negative 4, and this one ought to be separated into 2, whose product to negative 12. So how do you get negative 12? 1 times 12. Negative 1 times 12. Negative 2 times 6. 2 times negative 6. 3 times negative 4. Negative 3 times 4. Parenthesis for this one. And that's it. There's nothing else. So which one would be a good separation for this guy? Negative 6 and 2. So I found the one. This is going to work again. The product of these two guys should be the same as the product of AC, which is negative 12. Now you have the common factor. Common factor 2 here. Common factor x minus 2 and 3x plus 2. We did that before, so this is not a news here. We had the same factorization before. We used trial and error. Okay? You could ask you a question. Which one of these two methods is better? I don't know. Depends on your preference. I gotta say this. Whenever this one finds a factorization, trial and error, this one will find it. whenever this one finds a factorization, this one will find it. So they are so-called equivalent. You have like a two detectives. They're equally good or equally bad. Whatever this one can factorize, this one can do the same. So it's a preference issue. Again, when you have a big numbers, the trial and error might be difficult to work with because you're going to have lots of choices. When you have the smaller number, the trial and error is perfectly good. So that's a preference choice. You should know both. Now the difference about these two methods in terms of understanding what you're doing is when you are dealing with trial and error methods, you systematically outline all of the options and you go through all of them. And you'll find the one that works. When you're doing AC method, you're really doing something you don't understand. Because in this particular method, this magic, when you split the middle term so that the product of those two numbers is equal to the key number, why is this going to work? Why is that actually working as a factoring by grouping? And no any other factoring by grouping, and no any other separation would work. That's a question for a little more sophisticated algebra we're studying in our class, so we're not going to do that. It's a story about what we call in algebra congruences, and we're not going to study that at all. But it's not really difficult, it's just a little more above our class. So we're going to leave that as you know, the method that works, but you really don't know what is the justification. I'm not giving you justification of the method, I'm just telling you this works. And there is a justification, of course. There's nothing mysterious about it in mathematics. There's no any beliefs. In mathematics, everything that is there can be justified. Right? So that definitely works. So this is science. Both of them are equally good. Your choice. Okay, I'm going to stop here. This is the end of the story of the lecture number 12. The lecture number 13 is our next goal, which means actually that our exam that's supposed to be on Wednesday or Thursday, whatever that is, it's going to be delayed for the next week. So we're going to have the next Monday. Okay? That'll give you more chance to do work on the homeworks, to prepare yourself better for the exam, and it will give me a chance to finish lecture number 13 rather than to leave that for the test number 4, because I really want to have that lecture on the test number 3. It's also about special products. It's sort of a factoring business, and I want to round this as the last topic for the test number 3. So the test that we have, the test number 3, is going to be on the April 27, which is the next Monday. Okay, I'm going to put it as an announcement, so if anybody was not preparing anything, you can procrastinate a little more. Of course, that's not a good idea. So I am done with this lecture. This is lecture number 12 completed. You can work on that homework number 12, which is a long homework. And then there's a little shorter homework on the special product. This is number 13. And that's going to be on the test number 3. 9, 10, 11, 12, and 13. Those are the homeworks and the lectures relative to those homeworks, or homeworks relative to those lectures. You make sure you study that, because the next time we have a test on Monday. After that we have just about 3.5 more weeks to go, and then we are done with the class. Okay, so you're not going to have a time to catch up anything if you're not studying now. Okay, I'm done.